previous video, I have explained you about the capacitance of a spherical shaped material. What is that? 4 pi epsilon 0 r. This is the capacitance of a spherical shape. Now, what will be the capacitance when the surrounding medium is not air? Then the value will be 4 pi epsilon 0 into epsilon r into r, where epsilon r is relative permittivity. Okay. Now, we can't store charges in a spherical shape, in a spherical metal beyond a limit. Why? Because whenever we are increasing the charges, that increases the field, and when this field is more than the dielectric strength of the surrounding medium, then discharging will occur. So the maximum limit is nothing but the dielectric strength of the surrounding medium. Beyond that, we can't store charges. Now, the other way to increase capacitance is using a parallel plate capacitor. So where I will keep a plate in this way, and other plate will be there, which is placed parallelly and face to face. We will be charging the charges on one side of the plate. So whenever we are charging, what will happen? I am charging on one side of the plate. Basically one plate I am charging. Now when I am charging, this is a thick plate, right? It has two sides. Every plate will have two sides. One is this one and other one is the other side. There will be polarization occurring on this metal. What will be the polarization? These positive charges will attract the negative charges to one side, which is closer to the positive charge, and positive charges will be repelled to the other side. So when we are charging one side with positive charge, this will attract negative charges one side and take positive charges other side. This is induction, or this is, I can call it as induction, and the result is polarization. You know, charges as polarized. Still it is neutral. The net charges will be 0 because positive and negative, positive, equal positive and equal negative, net will be 0. Now, what has happened to the potential of this plate? Previously, let's say the potential is 100. Okay, and I have charged, like for example, 100 coulombs. Now, what will be the capacitance here? 100 volt and 100 coulomb. So, capacitance is nothing but, C is nothing but Q by V. So, Q is 100 coulombs and V is 100 volt. So, capacitance, for example, 1 farad. This is just for an example, okay. 1 farad is, practically not possible. We'll be measuring in microfarads or nanofarads. Now, anyway, 1 farad is the capacitance now. But when we are doing in this way, we are not doing anything with the charges. Charges are still the same. Total number of charges is 100 coulomb. But what we have done, this has induced, 100 negative charges here and 100 positive charges here. Now, whenever we are having two charges, 100 negative and 100 positive, these charges will, place a potential here. These charges will induce a potential here. Now, when this is a negative charge, the potential due to a negative charge will be a negative value. This will be positive value. Now, the negative charge is very close to the positive charge. See, the distance is less and the distance is more. So, let's say the negative charge is giving a potential of -60 here. And due to positive charges, that will be comparatively less because potential is inversely connected with distance. Now, this is shorter distance. So, negative charges giving on this side will be more potential as compared to positive giving on this side. So, anyway, negative is giving -60 and positive is giving, say for example, +40. Now, what is the net potential here? This gives a potential of 100 volt on itself, and this one gives, negative plate gives -60 and positive plates gives +40. Net potential will become 100 -60 +40. This is -20. -20 plus 100 plus 80. Now, capacitance has increased. How? Because now the charge is still the same, 100 coulomb. But what has happened to voltage? potential has decreased. Now this has become 80 volts. So 100 by 80 will be more than 1. Now I can increase potential with one more step. What I can do, if at all, if I am able to eliminate the potential due to these positive charges. Let's say if I am able to eliminate the plus 40, then still I can reduce the potential. What will be the value? 100 minus 60, that will become plus 40. Now when I am placing plus 40 in this equation, again capacitance will increase. Now I have to eliminate this positive. How can I eliminate? I can simply connect this side of the sheet to earth. What will happen? This is called as earthing. Electron will come and diffuse with these positive charges, thereby neutralizing this side. So there are two forces on positive. One reason why the positive electrons are coming to this side is nothing but this is at higher potential, this is at lower potential. Electrons will be coming in this direction. And one more thing, these positive charges are repelled by this side. So positive are repelled by this sheet. So it has a tendency to go down. With these two processes, these positive charges will be eliminated. Now what is the potential here? 100 minus 60, 40. Now the total potential has decreased, but charge is still the same. 100 coulomb here, plus 100 coulomb here, and minus 100 coulomb here. So on one sheet it is 100 coulomb divided by potential is 40. Now the value is more than maybe what is this 2 and above. So this is how we are making parallel plate capacitor, and this is the basic principle. Now we have to find out the value of capacitance. How we will find the value of capacitance? We know the equation Q is equal to CV. Okay, now we know the electric field in between two parallel plates. We have learned in which chapter? First chapter. If you don't know, you can use this equation. V is equal to E into D. We have to substitute the value of V here, right? And electric field in between two oppositely charged infinitely long plate is sigma by epsilon 0. You can refer your first chapter. Now that into what is the distance in between these two plates? I am going to take it as D. Okay, distance in between D itself, distance in between two plates. So this is D. Now substitute in this equation. C is equal to Q by V, and Q by what is V? Sigma by epsilon 0 into D. And we also have learned what is sigma. Sigma is nothing but charge density, surface area density. So what is that? Sigma is equal to Q by A. So charge stored in unit area is sigma. So I am going to substitute it here. So Q divided by sigma is nothing but Q by A into epsilon 0 into D. So I have just substituted for sigma as Q by A. Everything else remains same. So Q can be cancelled. So this is 1 by D by epsilon 0 A. So that is nothing but inverse of it. Epsilon 0 A by D. And this is the value of capacitance in a parallel plate capacitor. Thank you.